Welcome everyone, good morning, good afternoon and good evening. So today I'm going to walk through a presentation here regarding WorldSim and potential use cases. I'm going to go over a little bit about what WorldSim is for those of you that don't know or are not familiar with the product. I'm going to talk about some specific customer use cases, talk about expanded use cases beyond the traditional use of the tool, give you some insights into how it integrates into ADAS development, focus in a little bit on specific sensor processing. In this case, it'll be camera image processing. And like Megan said, we'll have a Q&A session at the end here. So there's 5 distinct sections. So I'm Iain Dodds. I'm North American Technical Director for VI-Grade. I am also the product owner for WorldSim. VI-Grade offers several tool sets within the simulation space. We have Car Real Time, which is our vehicle physics simulator. We have NVH-Sim, which is our sound and vibration simulation. And then we also have VI-WorldSim, which is our visual engine. And give you a little bit of what VI-WorldSim is. It is our high-quality graphics engine, traditionally used as a front end for a simulator to simulate the world in which you're driving. It's based off of Unreal Engine. It gives us all the capabilities very similar to what you see in the video game market, but much higher quality with a much more engineering content to it. One of our claims to fame is very intuitive and easy to use. We have a very nice user interface that you can author up scenarios and create your content with. We have a powerful traffic engine within VI-WorldSim that can control the vehicles, the pedestrians, and the animals within the space. We can also simulate sensors. So as the vehicle is driving down the road, we can simulate a sensor feed for camera, LiDAR, radar, ultrasonic, a lot of the common sensors that you see within the ADAS space. It is fully integrated with our driving simulators. So you can actually get the driver's subjective feedback as he's driving through the virtual world. And like I said, it's a very powerful authoring engine, and we include a lot of pre-configured scenario types within the WorldSim product. So let me give you an overview of WorldSim. WorldSim operates in 3 modes. The first mode is Author, which is through our studio product, where you can lay down vehicles, import your worlds, make interactions of the vehicles and plan routes and triggers and various other things within there. You can apply sensors to vehicles, and you can basically configure the scenario in which you want to drive through. Then we can run WorldSim in simulation mode. And in simulation mode, we can do that offline and online. So offline allows you to integrate MATLAB and our API. So you can do offline simulation, step-by-step simulation, a lot more detail for plugging in to the back end of the simulation. And then online, which is the traditional use case, which is the graphics in front of a driving simulator, that can work on a single to multiple projectors in an integrated fashion, so you can actually stick it in front of one of the simulators and drive the environment in an online mode. I'm going to give you some content here with regard to the graphics qualities and what can be done with WorldSim. We have a very talented content team that creates a lot of our worlds. We have several locations in the world that are GPS accurate. Right down to tree placement and signage. So what you'll see here is we have VI-WorldSim output and a Google map from the Street View output. And as you can see here, very, very close representation, digital twin copies of those worlds, right down to trees placement, grass, curbs, you name it. I think the only thing I say that doesn't change is the gas price at the gas station here within Wolfsburg. Another example, we have about 13 miles of downtown Chicago mapped out. Here's an example here of the WorldSim output. Here's an example of the Google Maps output. Some familiar landmarks are also modeled in sufficient detail that you can actually interact with the world and know exactly where you are within the scene. And then we also have several racetracks for the motorsports industry, where we have the tracks mapped out with sufficient detail that you can actually see the representative landmarks, the buildings, and such like within WorldSim. WorldSim also offers a set of graphics quality. We're getting closer and closer to what I call photorealistic graphics. Very similar to what you see in the video game industry, we can actually run the simulation at various levels from a basic graphics to an ultra level. And also within our ADAS sensors, we can control the quality of the camera output. So here's an example where I've placed a camera within a scene. We get the field of view of where the camera is placed within that scene. And I can control the quality of the camera to control the level of rendering. And this is based off of Unreal Engine, so we can take advantage of features like nanite and lumens to give you a very photorealistic view of the world. And this can be rendered and output in real time as the simulation is running. So some of the features within WorldSim, we have a fairly extensive library of digital twins. Digital twin can be applied to the environment. We offer, a sort of pre-packed set of environments for highways, a couple of tracks, some urban environment, residential and proving grounds. We can also create content. We provide tools for you to create content. I'll cover that in a later slide. We have a library of about 130 vehicles, several obstacles and pedestrians, as well as some animals that you can place within your scene. And like I said, we have the ability for you to bring in your own vehicles and your own objects, so the libraries are extensible. If there's a particular regional signage or regional feature that you want to bring in there, if you have the 3D model of that asset, you can easily import it through our mod kit into your digital world. Content creation, there's a lot of interest around people creating their own content. You can only go so far with the content that we provide you. We offer several ways of getting content into WorldSim. One is through the MathWorks Roadrunner tool, which allows you to create the road network and a basic background information, tree placement, grass placement, structure placement. And then you import that through our mod kit, and you can actually enhance that in the content, and then you bake that and export it to your WorldSim session, and you will have your own content. We offer a VI-WorldSim mod kit, which allows you to, like I said, import worlds, vehicles, and obstacles. We also have a set of helper tools because these worlds are very complex. There's road network definitions and all the underlying metadata that's required in order to interact with the digital twin. So we offer some tools supported within the Blender toolset for editing the path and checking out your vehicle models. And then we're also working on procedural generation methods for using path definitions and road definitions to automatically create a base map that you can then enhance within the Unreal Engine. Very, very flexible. One of WorldSim's strengths is our ability to author scenarios and interactions of how the vehicles operate within the world. We can place actors within the scene, whether it's a pedestrian, a vehicle, or an obstacle. We can define paths for that vehicle to pass through. We can define triggers on how vehicles interact with other triggers. We can put obstacles in the way of the vehicles so that they become collision aware and the vehicles would have to avoid them. WorldSim also has complete control over the environment in which the driver is driving. We can control the weather. We can make it rain. We have fog. We have overcast conditions, and we can even lower the temperature and make it snow. So a lot of behavioral definition on how you actually author your scenario before you actually go and drive it. WorldSim also offers an offline toolkit. We have an API that's available in Python, C++, and in MATLAB Simulink. We offer a lot of the connection blocks within Simulink for you to tap into the WorldSim data feed, and you can integrate that with your car real-time physics so that you can have an offline simulation feeding data to your post-process events within MATLAB, where you can then set up control algorithms and various other things within the MATLAB environment. But full access to the complete data feed from WorldSim is available offline through Simulink. And like I said, the primary use case is a front-end graphics engine for a driving simulator. And VI-Grade offer a lot of different driving simulators for different use cases. Everything from a desktop up through the compact for a single driver sit within the vehicle. We have compact FSS, which is the full spectrum simulator, where we can simulate 0 to 20,000 hertz, everything from the road vibration coming in all the way up through the audio range. We have a compact HMI simulator where you can actually integrate your controls and drive within WorldSim being projected in front of you and evaluate driver interaction with the vehicle. We can offer a static simulator, which is a modified buck that sits in front of the simulator. And then we get into our larger dynamic simulators that sit on top of hexapods, and ultimately the DIM, which has the large lateral motion. All of these can be run off of, all these interact with WorldSim, and WorldSim is an author once, run many. So if I author it on my desktop, I can run it on any of these platforms up to the DIM without altering the scenario. So let's talk about a couple of customer use cases here. These are specific customers, just to give you an idea of how people are using our tool, and then I'll expand on possibilities how you could use the tool. So we have a strong partnership with M-City. M-City have a proving ground in Michigan, Ann Arbor, Michigan, where they do a lot of autonomous vehicle research. They have one of our simulators, and they are working with us to integrate the simulator into helping them do dangerous use cases with the real vehicle where you couldn't simulate it in the real world, or you couldn't experience it in the real world without causing harm to the driver. So we have a compact simulator out in M-City where we actually have integrated vehicle handoff and handover controls for level 3 autonomous vehicles, as well as object behavior within the world, tricking the vehicle to thinking that there's a real obstacle within the world. Now, let me show you a real use case of this. Here's a use case where we have the digital twin of WorldSim as well as an autonomous vehicle. As you can see here, this is the WorldSim scenario. WorldSim has placed a vehicle in front of the autonomous vehicle. The autonomous vehicle can't negotiate it, so we have to take manual control. So this gentleman here is actually driving the real car through the digital twin to help the autonomous vehicle navigate around this virtual object. In the real world, that virtual object is not there, but the vehicle and all the sensors think it is. So this is a co-simulation, real-world autonomous use case where our object injection and sensor fusion can help simulate and solve some really interesting autonomous problems. We also have a very good customer here with Lamborghini. They use our simulation from a HMI perspective. A lot of the dashboards and the control panels that are within the simulator are simulated in the context of actually driving down the road. So it's not just an evaluation of what does this screen look like, but it's an evaluation of how the driver interacts with the vehicle as they're driving down the road, giving them the full experience of in-cockpit HMI interaction. They actually have one of our compact simulators, and they were one of the first customers to buy one. And this is a fully configurable HMI simulator where we can actually adjust pedal position, steering wheel position, as well as seat positions, fore, aft, lateral, and cross car. We can integrate multiple custom displays, and then the user can actually drive the vehicle in the context using WorldSim as the visuals and interact with their HMI displays. Another feature within WorldSim that people don't realize is we can actually simulate a lot of the headlights. We get very good photorealistic output from the graphics engine, and we've just released our advanced headlight feature, which allows us to control the headlights in many fashions. One example, as you're seeing here, is what we call active headlights, where we can control the angle, pitch, and yaw of the headlight. We've also introduced the ability to bring in IES profiles to define how the beam is projected down the road and preview those in the context of driving. And we can also simulate matrix LEDs, where we can actually isolate portions of the road based on where the LED is on or off. EDAG was a great partner in helping us develop this, and they are using this within their development process. They have a fairly extensive set of workflows where they define how the light is emitted from the vehicle. We use EIS profiles to define that light emission, and then they can actually simulate that. We provide a tunnel environment within WorldSim where you can actually evaluate, and it's a very common evaluation to evaluate how the light's projected down a dark tunnel. And we can also dynamically change how the beam profiles are done on the fly as the simulation is running. So you don't have to stop the simulation in order to change the profile of the headlight. And you get very accurate headlight evaluations and perceptions as you're driving within the simulator. So let me talk a little bit about expanded use cases. And these are the use cases that people don't necessarily think WorldSim is used for, but can be used for. And these are all projects that are real and I've been involved with over the years here. And we'll start down here in the lower corner here. Traditional use cases using as a driver in the loop simulator, using as the graphics in front of the simulator, using our drive sim and car real-time products to simulate a world and drive through that. But you can also use WorldSim in the context of hardware in the loop or hill, where I can actually feed third-party tools like a Rohde & Schwarz radar simulator, and I can take sensor feeds from within WorldSim and actually drive a signal generator that creates a radar signal that goes to a real radar sensor. We can integrate into third-party tools that use a lot of camera imaging type things like OpenPilot, and we can also point the camera at the screen if you want to do camera in the loop. We have a co-simulation where I want to take the best of both worlds. Let's say I want to integrate a traffic engine such as Sumo, or I want to integrate an output from S-Mini for open scenario, or even an additional potential third-party simulation engine like Carla, where I want to co-simulate with WorldSim and these environments to take the best of both worlds. We can have a dual digital twin in both worlds and co-step the simulation through and take the advantage of using multiple tools within WorldSim. We also have advanced simulation options such as virtual reality for full immersion, and we support the full OpenXR capabilities for immersing people within the WorldSim environment. We can do headlight simulation and traffic simulation. We can integrate sensors into tools, and I've got further examples to show of this, where we can integrate into a GPS simulation and sensor output and MathWorks. We can also do sensor processing, such as perception algorithms from camera images through our Python API and C++ API. And then we can also integrate with ADAS tools for planning, such as AutoWare. There's a ROS output, there's Python, and there's MATLAB Simulink. So let me give you a little bit of detail on some of these additional use cases. Over here, we have the Rohde & Schwarz radar simulator, where we actually use the AS/AM OSI standard to create radar messages from WorldSim. So in WorldSim, I have a vehicle with a radar placed on that is producing an output on a frame-by-frame basis from the simulation that is then being fed through an OSI message to a piece of hardware created by Rohde & Schwarz that generates a real radar signal. That radar signal is then sent to the radar emitter that emits a signal as if there was an object at that distance in the azimuth in front of the vehicle, which can then be beamed down to a real radar sensor that produces CAN bus messages that can then be brought back into the simulation for the control loop and close the loop. We also offer camera in the loop, where we have calibrated cameras. If you want to use the real camera, point the camera at the WorldSim screen in front of it, and then use the camera feed from the real camera. We can do simple things like lane detection, object detection, or more advanced things depending on what your camera is capable of doing. And then I don't know if any of you know about the tool called OpenPilot. This is an aftermarket open source tool for ADAS control on your vehicle, where you can actually integrate a dual camera AI capable detection tool that can actually detect the road, do emergency braking, lane keep assist, and those types of things. And we have an example here. We've actually integrated the WorldSim feed into the camera feed of this, and then allowing it to use its AI capabilities to control the vehicle within the simulation. Co-simulation, like I said, here's an example where we've actually got a Carla simulation and a WorldSim simulation running simultaneously. The vehicle is in step where you are. Co-simulation is something that, you know, if there's a feature within another tool that you're interested in using, for instance, maybe Carla has a slightly better sensor model that you want to use, we can actually use the co-simulation and take the best of both worlds. It allows you to integrate with the rest of the VI grade technology stack. And it's also can be used as a stepping stone if you're migrating from a tool and you want to do some cross correlation. Co-simulation is incredibly useful. Another example here is where I've set up open as-many. As-many is probably one of the standard and best open scenario players out there. So here we have as-many running a scenario within its world, and here we have WorldSim taking its instructions on where things are within the as-many world. Both simulations are running in step here, and as you can see, I can then take the WorldSim data feed and send that downstream, but it's being driven by the as-many simulation up here in a co-simulation mode. I talked a little bit about headlight simulation. There's a little bit more detail and some more examples where we're actually projecting the EIS profiles, no, the IES profiles, I'm sorry, where we can actually have a separate profile for low beam and high beam, and we can then dynamically change that within the simulation. At the end of this video here, you'll actually see the matrix headlights being displayed, where we can actually turn off portions of the light, and this is useful when you want to have use case of a vehicle coming towards you, and you want to have the high beams remain on, but isolate that vehicle from your field of view. So that can also be simulated within the headlight features. All the headlight controls are available through the API, and you can also available through MATLAB and Simulink, and you can integrate your headlight simulation within your real-time simulation within the VI grade technology stack. Our VR capability allows for VR pass-through. We have the ability to actually use a green screen to block off areas and pass through real aspects of the real world, whether it's the steering wheel or the user's hands, so they get some field of reference of where they are within the vehicle. Within the vehicle here, you see that we can simulate the dashboards. We have heads-up displays. We have the optically correct mirrors. As you're moving your head around here, the images actually update within the mirrors. All of this can be run in real time, and then when integrated with VI grade technology stack, you can actually drive the vehicle within this world. Very good use case for getting a feel for a broader interior, real interior of the vehicle when you don't have that developed. You can also get a much more immersive experience looking behind you, looking above the vehicle, interacting with the vehicle in the VR space. And this is all done in real time. Interior evaluation, we can get very high quality interior renderings. Here's a couple of examples of interiors that we've rendered up, where we can actually render up the real interior, project the real dashboards onto the vehicle, and then drive the vehicles. The steering wheels will move as you drive. And as I say, within the VR space, this becomes a much more immersive experience for the driver. Another off-the-wall type simulation is we have the ability to put cameras on static objects. So if you actually want to start doing traffic planning or traffic monitoring algorithms and start developing those, WorldSim has the capability of feeding that data to your algorithm. So we could simulate a high dense traffic where we want to do vehicle detection, traffic counting, lane counting, traffic control type algorithms, parking lot monitoring, parking lot algorithms. All of that can be developed with the visual capabilities of WorldSim. Simulated sensor integration. We have a couple examples here where we've been developing with one of our customers a heads-up display where they want to have the navigation capabilities put into. Next. Let me just mute that. Okay, where they're integrating the nav system into the heads-up display, and they're using WorldSim as the digital twin to evaluate. All of our real-world locations are GPS accurate, and you do get a GPS signal, so we can simulate a GPS constellation and feed to your nav system. We have an example here where we're driving in downtown Chicago. We have a nav system tracking that vehicle and providing directions as you're driving the vehicle. So you can actually integrate a lot more than just the visuals, and you can start evaluating, developing your nav system or something that may be sensor dependent within the simulation as well. So I'm going to talk a little bit about ADAS development and how WorldSim can be used to enhance your ADAS development process now. And in order to simulate ADAS, you really need three elements to come together. One is content. You need worlds and visuals in which you drive. You need to place vehicles, obstacles, and be able to have custom expandability of your worlds. And then once you have your content in place and it's digitally accurate, we need to have behavior. How those objects and vehicles interact with that world. How do I simulate the weather? How do I simulate, I want someone to pass me and then change into my lane very quickly. I may want to simulate a collision event, a dangerous event. I may also want to allow all the vehicles to be controlled by some traffic agent, so they have an independent view with different levels of aggression. We can simulate all of this within WorldSim as well as a co-simulation feature. And then we need to have sensors. So we have to be able to simulate the sensors to give feedback of what the vehicle would be seeing or sensing within the situation that you've placed it within its world. WorldSim is very good at simulating all three of these and bringing them together to support your ADAS development. So some use cases, and this kind of covers the span of how people would use WorldSim within ADAS development. And there's I'll go into details of each one of these, but everything from data generation up front, where I want to do a lot of data labeling and data generation from ground truth. I may want to simulate with the ground truth. Because I control the simulation, I can tell you where everything is in that simulation, and I can use that to validate, how my perception algorithm is seeing the world. I may want to actually simulate those software sensors and integrate them into my algorithm, a camera feed, a radar feed, where I want to develop a post-process algorithm using a software sensor. I then may want to bring in a hardware sensor into that loop. I then may want to bring my ECU in and actually feed signals from the WorldSim simulation directly into my ECU. I may want to do some scalable ADAS validation. And then ultimately, I may want to integrate that into a driver loop simulation where I actually get driver feedback on how they feel when that ADAS algorithm takes control of their vehicle. A little bit more detail behind these. Data generation. A lot of the ADAS algorithms are moving into the AI space. They're using a lot of machine learning capabilities, and you need a lot of data in order to train those algorithms. One of those training is basically data labeling, where in the real world you'd go out and you'd videotape driving through an urban environment or an environment where there's pedestrians and traffic, and then you'd actually highlight or pay someone to highlight and label everything within that frame. They put a bounding box around a vehicle, say this is a vehicle, this is a pedestrian, and then you'd end up creating a data set with a frame-by-frame image that you can feed into your algorithm for machine learning training. WorldSim is very good at generating data on the fly in this format. I can label and create training data sets in real time for various scenarios. So it's a big time saver and an enabler for starting your ADAS labeling development within data generation space. Like I said, simulating with ground truth, I want to be able to identify objects that I can then use for validation of my perception algorithm, whether it's a lane detection, or using a semantic camera where we actually isolate objects and label them and color them within the scene. I can tell you that this is the water tower, this is the road, this is the curb, this is a tree. We can have a depth camera where I can actually control the shade of the image based on how the depth of the object away from the sensor. And then we also have a virtual camera, which gives out the ground truth simulation for sensor validation. Very powerful tool. We can also short circuit all of that if you don't have the perception algorithm ready, but you want to work in a control algorithm. You can also use the ground truth sensor as the definition of your world to drive your control algorithm as well. But ultimately, you want to get into running your perception algorithm. And if we start here within the simulation space, think of this as all of the components that come together to make a vehicle simulation, whether it's an environment or an event or a control algorithm or some sort of hill integration. This represents the VI-grade technical stack. And from that, I end up simulating a scenario where the vehicle is driving through the environment in VI-WorldSim. Let's just say there's a camera connected to that. That camera would then give a frame-by-frame feed out of WorldSim that can then go into your AI perception algorithm to potentially detect those lanes. And then you end up processing that, taking an action or a plan from that and feeding that back into the simulation on a step-by-step basis. Then I want to go to the next step and I want to bring in a camera. So I have a real camera that I point at the screen that is using its output. I want to evaluate, maybe different manufacturers or different capabilities of that camera. And I can use that camera integrated within the simulation, use our hardware and loop capability through our camera in the loop rig to actually integrate the camera within the simulation. We could do mixed mode where I simulate some of the sensors and have some real sensors coming into the loop. And then I want to feed those sensors into a real ADAS controller. Now that ADAS controller does three things. It does perception, which is, perceiving what the sensor is trying to tell it. It does an action and plan, where it plans what level of output do I want, and then it has a control signal output that actually sends that signal. Could be something as simple as providing a HMI haptic feedback to the driver. I buzz the seat, I flash a light. Or it could be some level of control back to the vehicle. I want to apply the brakes, apply the steering, so on and so forth. And this would be a typical ADAS control loop with the ADAS controller in the loop, being fed from WorldSim and real sensors. Ultimately, you want to maybe evaluate where your ADAS algorithm is not operational, because there are boundary or edge cases. And this can be done in what I call a masked simulation DOE, or scalable scenario execution. I author a scenario of a vehicle driving down the road, and there may be an event where the vehicle passes me and turns into my lane. And I have a perception algorithm where I'm actually running the camera to run a perception algorithm to detect that event happening. But I want to know, does it work at 10, 20, 30 miles an hour? Does it work when it's snowing? Does it work when it's foggy? We can actually vary this scenario and create effectively a DOE of variations, changing the parameters in the scenario, running them on mass through your ADAS perception algorithm, and then generating a report which can be used for continuous integration and development of your ADAS algorithm that says, here's the boundary cases where your algorithm didn't work. You can then modify that algorithm based on those cases that were identified and run through this again. And obviously this is a growing library of edge cases as you expand how you want to test and evaluate your algorithm. So finally, I'm going to cover a little bit detail about examples of sensor processing. And in this case here, we're going to look at how WorldSim camera feed could be used to develop perception algorithms. This is down at the perception algorithm development stage. I'm going to cover it with 7 examples, and they're going to be video feeds here, so hopefully they'll play well within the webinar here. And our first one is using automatic data labeling for ground truth simulation. And here's an example where I'm running the simulation in real time, and what we're doing is we're using the ground truth sensor to identify objects that are being labeled, and what I'm doing here is I'm putting a bounding box around those objects and giving them a data label. I'm also generating a report in the background. I see when I go downtown here, it lights up like a Christmas tree, and I'm identifying all the objects. Now we can filter on these objects, say I only want to identify cars, I only want to identify road signs, those types of things. But at the end of the simulation, I get a report out that says, frame 1, I detected this object, a traffic light with this ID, with this bounding box and this size. And this can be fed directly into a machine learning algorithm along with the corresponding image frame to train it for object detection. This is typically how those are done. But what we're doing here is I'm generating this in real time. There's no longer manual labeling and creating a large workflow process that can be done in real time on the scenario the author in the world that you author, because we control the ground truth. Also within the ground truth, I can, through some tricky camera math, I can take the ground truth sensor that's identifying where the vehicles are within the scene. I can put a bounding box around that. So I can actually use this to identify if I have a perception algorithm that's actually looking to see where the vehicles are, I can actually identify that from the ground truth sensor and use that to validate. And here's an example here. And as we go down the road, you'll actually see the vehicle being highlighted within the scene in real time, and every vehicle is being detected by the ground truth sensor is highlighted in a bounding box placed around that. Again, an example here using the ground truth sensor with the camera sensor to do overlay of sensor fusion. Another example here is using the semantic camera, where I'm running the simulation up here, and then with the semantic camera I can actually isolate objects and give them a unique color within the scene. I can also filter on that object and say, only tell me the pixels within the scene where the vehicles are. So ultimately the output is this black and white image where I'm identifying pixels within the camera image that are only vehicles, and I could use that as a validation method for my perception algorithm within my ADAS development. We can do advanced image processing, where a lot of the lane detection algorithms actually doing a image reduction method, where I'm actually reducing that image down, providing a filter to detect those lanes and then superimpose those lane definition back on the simulation. So here's an example where I used a couple of open source lane detection image processing capabilities to actually do the lane detection. This is no longer ground truth. This is true machine learning perception image processing capability. So we can actually use this within our algorithm to determine how far we are away from the center of the lane and possibly integrate that into our control algorithm for lane keep assist. We can get a little bit more advanced using a trained algorithm to detect paint markings on the road. This could be then enhanced to refine this and use for identifying areas. But this was basically a machine learning algorithm that was trained to identify paint markings on the road, of which we run within WorldSim and apply that algorithm to identify regions that could be used for detection. There you go. Another one here is doing true object detection. There's an open source library there called YOLO, You Only Look Once. And what I did here was I actually took the camera feed from WorldSim and fed it into the YOLO algorithm. Didn't train it any more than what came out of the box. And with YOLO, I can actually detect road signs and vehicles from a WorldSim scene. So the graphics are of sufficient quality that the YOLO algorithm thinks it's looking at a real camera detecting these objects. I also get a percentage confidence of what it thinks it is. So if it thinks it's a vehicle, I get an 80% confidence level that it's a vehicle. And you can actually, integrate your algorithms within WorldSim, and the graphics are of sufficient quality that they can actually feed these types of algorithms. And then finally, sensors are never perfect, and there's always edge cases, sensor faults. We can simulate those within the WorldSim environment. I can simulate, raindrop accumulation and even bird droppings being put on the camera, which are real-world situations where I can actually start polluting the sensor output with faults and then using that to actually feed my perception algorithm within your ADAS development. So in conclusion, WorldSim has a expanded use case well beyond the typical simulation front end. As you can see, it's a very capable tool for doing a lot of independent use cases for your ADAS development, all the way right down to your perception algorithm development. Our API will allow you to get deep integration in there. Like I said, the API is available in C++, Python, MATLAB Simulink, and there's even a ROS output. And you can get deep into the integration and sensor feed from WorldSim. WorldSim also has the capability of integrating with your hardware in the loop simulations and providing data feed. And then all of these examples are available on our knowledge base. I've published these. A lot of them are Python-based examples to get you started and show you how you could possibly use WorldSim within the context of the videos that I showed you. And those are available within our VI grade knowledge center that you can download and try them out for yourself. And I'm more than happy to answer questions if you want a one-on-one session as well. So at this point, I'm going to open up for questions and see what you guys think.